understand the functions, first we need to understand that, generally speaking, there are quantities that are either related or depend on other quantities. For example, the amount of time it takes you to drive from point A to point B, it depends on what? One of them would be how fast you're going from point A to point B. Depends on traffic. There may be many other factors, but generally speaking, when it comes to physics and science and math, we are interested in a few important factors. So first, let's look at some definitions. Relation. Relation is defined as a set of any ordered pairs when we discuss the concept of ordered pairs, of course, we mean what? Generally speaking, X and Y. Now, the first coordinate is normally called X, the second one is Y. The first coordinate is also known as independent variable. The second one is known as a dependent variable. So, collection of independent variables this is called the domain. Collection of all dependent variables is called the range. So relation is known as basically any ordered pairs. Now if we restrict that to the following, if we restrict it such that the first coordinate cannot repeat, so any ordered pair is known as a relation. Any relation that we can have the same first coordinate, we call it a function. That's a simple definition. To understand this concept, we will look at a simple example. But before we do that, when we discuss functions, or relation for that matter, we can use pairs in the form of sets. We can use tables. We can use equations. To illustrate this fact and understand the simple case as far as a function is concerned, let's consider the following. One, 2, 2, 5, 7 minus 8, and 2, 51. B 1, 2, 2, 5, 7, 8, 9, 8. Let's look at those two sets. First of all, is A a function? Not a function. Why not? Two repeats. And by the way, it doesn't matter how many pairs you have as long as one of them is out of the picture. Does that make sense? Is this a function?
Yes.
Yes, it is a function. Yes, it is a function. The first coordinate should not repeat. If the second coordinate repeats, it's okay. Later on, we discuss what's known as a one-to-one function. And you ask yourself, is this a one-to-one function? Answer is no. We'll get to that towards the end of the course. And we need that in order to have an inverse function. But for now, is A a function? No. Is B a function? Yes. Okay? Can you give me the domain for A?
1, 2, 7.
1, 2, 7. And you don't repeat what you see. Just you write them once. What about the range? 2, 5, -8, 51. Okay, let's look at B. What's the domain, everybody?
1, 2, 7.
1, 2, 7, and 9. Range?
2, 5, 8.
2, 5, 8, 8.
2, 5, 8. Now, this is fairly simple. Most of the time in mathematics, we are interested in equations. Okay? And with that, many times we use what's called a function notation. Function notation, usually we use f of x, but it could be g of x, h of x, or you name it. And for all practical purposes, in order to make your life easier, just think of it as y. In other words, y is equal to f of x. And the way you read it is f of x. It's not f times x. Okay? F as a function of x. For example, when we looked at lines, there were 3 different ways to look at them, and we're going to have a lecture on that also. One of them is a standard form. One of it is a point slope form. Okay. And also y equals mx plus b. Slope intercept form. When you write and solve for y, you can now change it to f of x. So as far as you're concerned, I mean, understand, it's really, ultimately, it's the y coordinate. One might say, okay, why do we write it in that format? Here's the reason. If, for example, f of x is, let's say, 2x minus 1, and then they say, what is f of 5? What does that mean? You plug in. Precisely, you plug in. Let me just use a different color. You plug in whatever this one is, which happened to be 5, and that becomes 1. Now, what's really important is the meaning of this. F of 5 equals 9. What does it mean? It means if I were to graph this function, which happened to be a line, then this point is on it. Is everybody clear? The meaning of f of 5 equals 9, that means I can give you one ordered pair. I found one on the graph of this function. Sounds good? Is everybody okay with that so far? All right. Now, as I mentioned, we are interested in equations. So there are certain things that we need to know about it. What happens when we graph an equation? How do we recognize whether we are dealing with a function or not? And excellent. And we can come up with the graph, look at it. We can come up with the domain and range. So one way to recognize you have a function, when you graph it, what is it that you need?
Vertical line test.
VLT, short for vertical line test. If you're looking at the following graphs, simple case first. You want to figure out whether it's a function or not. You just come up with any vertical line which crosses the graph more than once. Do you see that there is no way any vertical line that you come up with, it just crosses the graph what? How many times? Once. How about this guy? So is this a function? Is this a function? So a graph represents a function if no vertical line crosses the graph more than once. That would be a test to see whether you have a function. Now, what's important to understand is, can we recognize the domain and range of a function as we look at the graph? And that's what we want to do here. So, we will look at those two, and we will look at a few more. This is a function, this is a relation, it's not a function. So let's look at this one. When you're looking at the domain class, the reason I spell out the range rather than just writing R, because I don't want it to be mixed up with the real numbers. All right. In order to find the domain, when a graph is given, everybody, in your mind, break the graph and put it along the x-axis, for the domain. For the range, put it along the y-axis. Now, look at this one. You got to realize, of course, that this goes indefinitely up, right? if you were to break it and put it along the x-axis, let's see, if you're looking at this, what do you think it will cover? Can you see?
Yeah, exactly.
Do you see it covers the whole x-axis? So therefore, the domain is all real numbers. Now, there are a couple of ways you can represent this. So let me make sure everybody understands what this means. You could say just or. You could say negative to positive infinity. Okay, class? Or you could say x between negative and positive infinity. And the reason I want you to pay attention to that, because when we say domain, it's all possible values of what? X. Domain, all possible values of x. By x we mean the first coordinate. By x we mean the independent variable. Is everybody clear? Independent variable. We don't use x all the time. Normally we do, so it's important to understand the meaning of the domain. Now, again, imagine you're breaking it along the x-axis. That's your domain. Now, take a look at it and now break it along the vertical axis, the y-axis. Which portion of the y-axis will it cover? Which means 0 to infinity, or you would say y is larger than or equal to 0. Do you see that? A more proper terminology would be non-negative, because when you say positive, you're excluding 0. Does that make sense? Great. So is everybody clear on that? So everything from 0 up is covered by the graph, isn't it? Do you see that, everybody? Now let us do the same thing with this relation. Let us find the domain. In your mind, break the graph and lay it along the x-axis. What does it cover? So, what portion of the x-axis will be covered? Do you see that? It's 0 to infinity, or you might say x is larger than or equal to 0. Is this making sense? Now at the same time, we are looking for the range. Now break it along the vertical axis, the y-axis. Which portion will be covered? All. She says all. Okay, what does it mean when we say all? All real numbers. Or you might say negative to positive infinity. Or you might say y is between negative and positive infinity. They all have the same meaning. I just want to make sure we can distinguish between the domain and range, between the x and y coordinate. Sounds good? Any questions so far? So that's the concept of a function, definition of a function, coming up with the domain and range as we look at the graph. So let's look at another interesting graph, see if we can figure out the domain and range with the way I just explained. Take a look at this one. This is an elliptical shape, and ellipse. We'll discuss it with more details in chapter 10 when we go over conic sections. And for now, we are just interested in finding the domain and range. First of all, is this a function class? Okay, why not? Just, even if you look at the y-axis, there are two intersections. So it definitely fades. So is this a function? No. Not a function. It fades the test. VLT, vertical line test. Therefore, it's not a function. Now let's look at the domain. Okay, I want to give you a minute. Again. See if you can figure out the domain and range. You're looking at the graph, and in your mind, you break it and you lay it down along the x-axis. That would be your domain. Which portion of the x-axis is covered? That's what you're asking us. So what is it that it can cover? No. Say it again.
-3 and 3.
Do you see that, everybody? In other words, this is the same as saying x is between -3 and +3. If you lay it along the x-axis, it only covers from here to here. Does that make sense? Go ahead.
And you put it in brackets because it includes the negative.
Why did we put it in brackets? Why not parentheses? The endpoints -3 and +3 are also included. Okay? Everybody clear? All right. What about the range? Do the same thing. Lay it along the vertical axis. What do you have? When you put it in an interval format, it must go from small to large. So it must go from negative to positive, okay? It means y is between the two numbers, between -2. In other words, this is your domain. And the red piece is your range, going from here to here. Domain from here. So that's the basic idea behind functions. Sounds good? Any questions? All right. Now we want to discuss algebra functions. Okay. When we discuss operations on real numbers, normally what operations are we referring to? Operations on real numbers. Multiplication, addition, subtraction, and so forth, right? We can discuss the same concept when it comes to functions. Okay. Now, so we have the sum function. F plus g of x is defined as f of x plus g of x. The difference function f minus g of x is defined as f of x minus g of x. The product function f g of x is defined as f of x times g of x. The quotient function. F over g of x is defined as f of x over g of x, and as always, denominators can never be zero, right? So g of x in this case can't be zero. That's called algebra functions. Now, a very simple example. Would be following. The following. Let f of x, I don't know, x equal 2x squared minus 5x, and then g of x is, let's say, x squared minus x minus 6. A very simple example. So here's what we want to do. Last, we want to find this. Go ahead and do that. Let's see what you have. Find f plus g of x. So whenever you do algebra functions, first write the definition. Now plug in. So what do you have here? What is f of x? 2x squared minus 5x, and then we're going to add to it, and if you want you can put it in the parentheses, it doesn't matter in the first sentence. X squared minus x minus 6. You need to collect like terms and you end up with what? 3x squared. Okay. What did you say? And then finally, the constant, right? So simply add them up. When you add up, what do? Add up like this. The second one, the same thing. But you put a negative in between, which will distribute and change the signs. So this is 2x squared minus 5x minus x squared plus x plus 6. Is that correct? So what's the answer now? We have x squared. Right, everybody? What else do we have? Minus 4x, right? Because minus 5x and positive x, they add up to negative 4x. Finally, the constant. Does that make sense? The product class would be f of x times g of x. All right? Just multiply them up. And here's how we do it. I'm gonna I'm gonna use just a different color. And I'm gonna say ignore the second term. When you're multiplying this, that means 2x squared, the meaning is 2x squared times the parentheses negative 5x times the parentheses. Is that right, everybody? Again, that's one way to look at it. And now, the reason I put it in red, you don't have to write this step. If you decide to skip that step, that's fine with me. So let me use the red one so you see if you are multiplying the red one or just rewrite it. What do you get? Help me out. 2x squared times x squared is 2x to the power of 4, right? The exponential root, right? In this case, the product root. 2x squared times negative x, what is that? Minus 2x cubed, is that right? And then finally multiplied by the constant, right? Which gives us 12. Yes. Okay. Now, a different color is used, or we can look at what you have here. Either way, minus 5x times x squared. Okay, so you're multiplying this 2 or this 2 if you will. And then this one or this one if you will. What do you get? Plus 5x squared. And finally times the constant, which is what? And of course, there is one more step. You have to put together like terms. Is that right, everybody? Okay. It's a good practice class to put them in descending order. So everybody knows what we mean by descending order. So you look at the power and write the one with the highest ratio. The highest power first is called the leading term. So the first one, and I'm going to cross it out simply because it means, okay, I took care of the business with that piece, right? There is nothing else with the exponent 4, right? Then I go and look at the one with exponent 3. I find this one, and I find this one, right, class? They're considered like terms. Negative 2x cubed and negative 5x cubed, the result is? Negative 12x squared, positive 5x squared, they are also like terms. Therefore, I end up with, there is nothing else except the first degree term. And that would be the product of the two functions. Does that make sense? Now, I'm going to get the last one, the quotient function. The quotient function class f of x over g of x is equal to 2x squared minus 5x over x squared minus x minus. Now, whenever you have an expression in the form of a fraction, anything that makes the denominator 0 must be excluded. That's why we say g of x is not equal to 0. To do so, it must be factored out. And some of you remember some basic factoring, right? The top piece. The very first step in factoring is taking the GCF out. GCF stands for The greatest common factor. Is there any common factor from the top? X comes out. So what do you get? 2x minus 5, right class? The denominator, if you recall, and we will discuss that with more details when we go to factor. It's a trinomial. So you put the x here, you put the x here. The trial and error method says, what is b? -1. What is c is -6. We want two numbers. The product is -6, and the sum is -1. What are those numbers? And x can't be +3, -2. That would be the quotient. I want to add a couple more things quickly and pretty much that would be it. Now, with those functions, if somebody says, okay, we want to find, I want to erase this and I want to keep actually, I'm going to keep the first one. We want to find the following. We want to find f plus g of, let's make up a number. Let's say 4, okay? Rather than f plus g of x, we want to find f plus g evaluated at a specific value. For example, x equals 4. There are two ways to do it. One is fair. First and foremost, we find f of x plus g of x. We've already found it, right? And now you plug in whatever that they gave us, right? But that requires two steps. You have to find that and then plug in. The other one, you can say it's the same as f of 4 plus g of 4, right class? Do you understand that? And I picked this so, again, refreshing everyone's memory as to how to evaluate a function at a specific point. So, you can use this one. You already have the answer with the asterisk next to it. Plug in 4, okay? But again, remember, this has been done already for us, right? If it were not done, we had to do it, okay? That's one way. The other way is understand this is f of 4 plus g of 4, right? Now class, can you tell me what's f of 4? How do you evaluate the function at 4? F of 4. You say 2 times x squared minus 5 times x. What is it? Do you see this is f of 4, everybody? Plus g of 4. X squared minus x minus 6, and again, the same 4. The reason I'm going to use a different color because I'm going to the g function now. Does that work for everybody? All right, let us evaluate. Four squared is what, everybody? 16. So 2 times 16, 32. Minus 5 times 4. Minus 4, okay. 16 minus 4 minus 6. Okay. So what is this? 12. 12. 22 minus 4. Is that 18 class? So that's one way to do it. f of 4 plus g of 4. What do you think we'll find here? We can plug in here 3 times 4 squared, right class? Minus 6 times 4 minus 6. And what is 4 squared? Do you see this is what? 40 what? Minus? Is that 18? Again, understand this was done previously, so if we have it, we will use it, that goes fast. But if it wasn't given to us, then perhaps you want to do it. Yeah. All right. There were a couple of questions that were asked. I'm going to go over in a second. But as far as function notation, finding the domain and range, is everybody okay with that? Yes, go.
So when you come across a set of functions, fx and ux, they're going to give you those two.
Yeah, if we are interested in algebra function, then you must be given f of x and g of x to work.
And then they're going to give you the 4 to plug in.
Yeah, okay, so they give you f of x and g of x, they might say, okay, find f plus g of x. They might say find f plus g of 4. They might say find f g of negative 8. Yes, they give you f, they give you g, and then they say what it is that they are interested in. Sound good? All right. So I want to look at those questions that they were asked. Also later on we will discuss, I think on Monday we will go over linear function probability things. In any way, let's look at this couple of examples that somebody asked. By the way, when we look at functions class, we've already gone over some linear functions, okay? So just quickly, as far as the domain and range is concerned, if you look at this one class, or if you look at this one, everybody can see those are lines of linear functions, right? Can you see both of them are functions? Okay. We'll discuss vertical and horizontal line later on. But for now, let's go. And everybody can see that the slope is positive here. The slope is? Can you figure out the domain and the range for each one? Just by looking at it. Remember what I said? If there is a graph, just lay it along the x-axis. That becomes your domain. Lay it along the y-axis. Break it. Make sure. See what happens if you do that. What do they cover along the x-axis, class? Do you see they cover everything? You see the lines. Let's just do this. You look at this line, if you lay it along the x-axis, it covers everything, meaning negative to positive infinity, right? And if you go along the y-axis, it's the same thing, right? By the way, whether the slope is positive or negative makes no difference. A line, a linear function, where the slope is positive or negative, it will cover from negative to positive infinity as far as the domain and range is concerned. All right. How do you solve for a specific variable? In fact, when you solve for y, then you can replace it with a function notation and call it f of x. Now, a couple of questions that came about, I'm going to write them. We want to solve for z. We want to solve for m, and I added another one. We want to solve for capital. We come across cases like that in science courses, like physics especially, where an equation is given and you want to solve for a missing variable. Okay? And then you can try them many times. It makes it easier when you want to evaluate the missing variable, as long as it is something. So we want to solve for z. And there are actually, in some instances, this is an example, you have a couple of different ways to approach it. Okay? How would you solve for z? Any ideas? Let me see what you have in there.
Distribute p to y negative
So we get
py
py. So what are we solving for? You have to isolate that. Anything and everything that has z in it on one side. So in this case, you move the py to the other side. Do you see that, everybody? So how do you get the z by itself? Divide by negative p. When you divide by negative p, this is what you get, right, class? Now, this is one way to write it. It's not a good practice to have a negative as part of the denominator. But if you left it as that, this is correct. Everybody knows that, right? Do you also see this is equal to what did I do? What happened?
Times it by 1 and everything puts the
Just-
sign.
Just bring the negative sign up. Does that make sense? Go ahead. I want to go over that. And before I go over that, let me continue with this, just to make a point. Can you see this is also equal to minus W over P plus Py over P, right, class? Right? Can I separate them like that?
Yeah.
So what is the second piece? The second piece is? Now, do I have to do it this way? No. In fact, most likely, this would be probably the best answer. But it doesn't matter. It's your choice. Either way is fine. Okay? What is important to recognize, these two are identical. Got it? So here's what I'm going to do. I'm going to look at it from a different point of view. Could we divide by P? That was the question. And the answer is yes. Everybody. Here's the second method. Just divide by P. Everybody, divide by P. What do you get? Let's just if you divide by P, you get W over P equals Y minus Z. Right, class? So if I move the Z to this side and W over P to this side, this is what we do. In fact, this is a tad faster, as long as we are consistent. Does that make sense? What?
So with the answer that you circled with the arrow, is that, you said it's still the same thing, but is that?
All of it is.
But if it's not all the way simplified, isn't that wrong?
No, you got to realize sometimes we want the same denominator. Sometimes we want it this way. But this is good, this is good. This is not necessarily more simplified than this one. You just separate them into two fractions and then the second one got simplified. What's important to know, you can't drop the P and P here. You have to cut them into two pieces, two fractions. But is this fine? Yes. Is this fine? Yes. And not necessarily one is more simplified than the other. Not in this case. There's a common denominator. There's a common factor that you can drop to the denominator for all these. Everybody is okay with this question? You want to do this one. Number 2. What are we solving for? Okay. First you multiply by 2. If you multiply both sides by 2, what do you get over here? 2e equals
1.
m v squared. So in other words, multiply both sides by 2, right? So what's the next step? Divide by what? V squared. So 2e over v squared is m. Sounds good? Everyone? We got to get the last. By the way, most of these formulas, I think many of them should be familiar. For example, anybody remembers that one? A equals 1/2 h times lowercase b and plus uppercase b. That represents, anybody? Area of a, everybody can help out. Trapezoid. Area of a trapezoid. Remember that? Lowercase p, b, and uppercase b refer to different bases, if the bases are not identical. And in the case of a trapezoid, the bases are always different. All right. So what are we solving for? Capital B, right? So I'm going to actually solve it using the method that was asked for question number 1. First of all, we're going to multiply by 2 to get to that 1/2, right? If you multiply by 2, what do you get? 2a, and what do you get on this side? H times b plus b. Now the second method that was explained here, and it was asked, that means rather than distributing, you have to divide by h. So we're going to look at both methods, okay? We're going to look at both methods to make sure everybody's okay. So this, I want to show you the difference, and sometimes one is faster than the other, okay? If you are going to make a mistake, stick with just the method that you're comfortable. So a fast way would be, if you divide by h, what happens over there? If you divide by h, you get 2a over h is equal to lowercase b plus uppercase b, right? What are we solving for? Uppercase b, so just move the lowercase, and you get 2a over h minus lowercase b is equal to uppercase. Does that make sense? Now let's look at the second method. Second method, we're going to continue from this asterisk, from the start. 2a is equal to what, everybody? H lowercase b plus h capital case B. Yes? If you distribute, right? H times b, h times uppercase. And so, we are going to isolate this piece by moving this one over there. We get 2a minus h lowercase b equals h uppercase b. What's the next step? So the right side is b, and the left side is what you see. Can you see that number 1 and number 2 are the same? Do you see that if we take a common denominator of h, we get to this? Now, which method is easier for you? I have no idea. You have to decide. But I think it's good. It's good practice if you learn both. For sure, one is faster than the other. Sounds good? Any questions?